Now we're going to talk about how to use the zeros of a polynomial to help us get the general shape, the middle pieces of that polynomial, not just what the ends do as we sketch the graph. Now, again, these graphs are pretty boring. There's not much to them, but when we talk about a zero of a graph, we're talking about for what x values that y is equal to 0. So if we set x equal to 0 and solve for x, we find out it crosses one time right here at 0, 0. And if we set x squared equal to 0, x is still equal to 0, or x cubed equals 0, x is still 0. But here with our degree, okay, we know that there's two solutions to any quadratic equation, or there are three solutions to any cubic. It just happens to be that 0 is the solution twice here. We call that multiplicity 2. And over here, y equals 0. Sorry, x equals 0. We're setting y equal to 0 and solving for x. X equals 0, and it happens to be equal to 0 3 times. So we call that multiplicity 3. Over here, when x equals 0, it just happened one time. That's what we're used to. Okay, one solution, that solution is 0. Now, the multiplicity of a 0 or of a root, root's the other way we can describe that, tells us what's going to happen to the graph at that point. If the multiplicity is an odd number, like multiplicity 1, multiplicity 3, our left and our right graphs, then our sketch is going to cut through and start either below and go to up above the axis, or down here we started above and cut through to below. If our multiplicity is 1, our graph cuts straight through, like it does for y equals x. Okay. If we have a multiplicity 3 or higher, then notice how it has sort of a little bump right here. Okay. It kind of gets flat. It doesn't cut through in a straight line like it did with y equals x. If our multiplicity is 2 or any other even number, then when we hit that 0, it's going to turn around and bounce right back the same direction it came from. So down here on the bottom, it came from below, it bounced back down below. Okay, up here we started from above and we bounced right back up above. If we're curious what happens to a polynomial like our f of x that we had, okay, we know from the page before what the ends do, that they both go in the same direction and they both go up, but I don't know what happens in the middle. Now, one thing to keep in mind is that whatever the degree of your polynomial is, here it's degree 4, there are no more than one less than that, so no more than 3 turns or skips or changes in direction. Skips is not the right word. No more than 3 bumps or 3 turns in that graph. It may only have 2, it may only have 1, okay, but no more than 3. A polynomial of degree 3 will have no more than 2 turns in the graph, 1 less than the degree. Now, if I'm trying to find the zeros of a graph, we need to figure out when is this graph equal to 0. Or again, it might say find all the roots of the graph. Roots mean find when it's equal to 0. Understand that our most direct path to any to solving any polynomial when it's set equal to 0 is to factor it, if at all possible. Okay. Many of them are already factored for you in the book, but factoring, assuming we do have a comprehensive final in May, which is still up in the air, then factoring will be the very first thing you have to show me that you can do. And so we're going to practice factoring each of these polynomials. Because I have the right pattern here, I know that I can set this up as a grouping problem. The two factors of negative 24 that add to be negative 5 are negative 8 and positive 3. Okay, then when you take out the greatest common factor and we take it out again, we're going to find out that this polynomial factors 2x plus 3 and x squared minus 4. Okay, and I'm going to put little dots in here that you guys can show me the rest of the steps. If you can't show me the rest of the steps, then you need to give me a shout. Okay, we can talk about factoring in a separate conversation. Now from here, 2x squared plus 3 does not factor anymore, but x squared plus 4 does. If we set each of those factors equal to 0, and solve for x, this tells me x squared equals negative 3/2. Okay, what does that mean to us if we think about that for a minute? X squared is equal to a negative number. That means we have imaginary roots. Okay, x would be an imaginary number, a complex number. Okay, not in some situations we want to know what those are, but in terms of a graph, silly thing. In terms of a graph, we can't draw a picture of that. Okay, I want this guy out of my way because I want to be able to draw a picture over there. Okay, if we set the other factors equal to 0, we get x equals negative 2, x equals positive 2. Okay. When we go to sketch the graph of f of x, we combine all of our ideas together. We said the only two real roots, real solutions. So this happen at 2 and at negative 2. So here at 2, 0, we cross the axis. Back here at negative 2, 0, we cross the axis. We know that because the degree is even, both ends go up. We know that because 2 is positive, because 4 is even, they both go the same direction. Because 2 is positive, both ends go up. So I know from here, I'm going to go up. I also know that the multiplicity of each of these zeros is 1, so my graph is going to cut through that 0. It's not going to bounce back the other way. It's going to come down here and meet up with the guy on the other side. Now it may not be perfect there, but in terms of the zeros, it's going to only cross at 2 and negative 2. We know that the outside ends both go up, and in between it might have a little hump to it, but we don't know that for sure. All right, if we want to look at negative 10x cubed plus 24x squared plus 10x minus 24. Go ahead and pause the video, get this thing factored. Because there's 4 pieces to it, we can hopefully factor by grouping. All of these that I've chosen today are going to be that you can factor by grouping. And then we'll talk about what happens when you get it factored. Of course, the shortest path to get to these solution or to get it factored is to pull a negative 2 out, a 2 or negative 2 out first. If you didn't do that, then when you solve for x, you should still, if you're careful with your numbers, get x equals positive 1 and negative 1 and 12 over 5 for the zeros of that polynomial. Now, each of those roots are multiplicity 1. They only happen one time. That's awful. And so that means each time the graph touches that 0, it's going to cut straight through. So negative 1, positive 1, and let's see, what is that, 2.4. So negative 1 is here, positive 1 is here, and 12/5 is going to be between 2 and 3. Okay. And the end behavior on these is that odd degree means opposite directions. Negative 10 means we go down to the right, which we already had on the other page. We know that each one is multiplicity 1. So as it comes down from left to right, it's going to go down. I don't know how far necessarily, but it has to turn around to cut back through this one, and then turn around to cut back through that one. Okay, all I need from you on these graphs is the general shape. If I say, oh, nope, it's supposed to be down here at negative 24, and it doesn't look like you hit that, okay, because really it is supposed to be at negative 24. Okay. If you have the right shape and you do the right thing at each zero, that's what I'm after on these graphs. If we had lots of extra time, if we, I don't know, if we were worried about this in a lot more detail, then I would ask you to be a lot more specific. But I need you to start at infinity, cut down through -1, come back up through +1, and drop back down through 12/5. So that's the general shape we want. This looks like this. Okay, but you have to tell me specifically where those three guys are, which is here. On each of the rest of the polynomials, I've got h here on this page, and then I've got k and q and all of the rest of them. Go ahead and do what we just did. I can find it again, for each of the rest of those, and then turn it back on and see if you found your zeros correctly and have your sketch done correctly. All right, so hopefully you found your zeros to be 0 and -4 and +3. 0 and -4 and +3. Now, because 0 is a 0 of multiplicity 2, that means when I get there on my graph, it's going to bounce. It's not going to cut through like it did on the other ones. Okay, so I know even degree means both ends the same. -3 means both ends down, which means from here I'm going to go down. Multiplicity 1 at -4 means I cut through. Okay, when it was multiplicity 1 at the 3, also it cuts through. When I turn around, I'm going to bounce off of 0. Okay, and maybe I don't have my hills quite right. Maybe they're symmetric. Maybe this one's really big and this one's really small. Okay, I'm not worried about it being perfect other than that you've bounced off of 0 here and that you cut straight through here and here. So again, if you graph that on your calculator, you don't say, oh, Ms. Jackson's wrong, that right hill is supposed to be taller than the left. Okay, again, I'm after general shape here because that's kind of what we have with our time frame. Okay. Okay, you can pause the video and scroll through on your own here in a minute, but on K, there was only one real solution, and the reason I put this bump here in it instead of just going straight down, I know the right end goes up and the left end goes down, but I put a bump because of the x to the third. Okay, it's not a straight line unless it's x to the first, but x to the third means it's going to have a little bit of a curve, so I kind of made up what I thought that looked like. I apologize, but on Q, it has no real roots. Don't worry about a graph there because without it, you would have to do a lot of other things. When I made these up, I sometimes get in a hurry, I guess. R has a multiplicity 3 root at 0, which means instead of cutting straight through, like up at the top function there, it kind of flattens off as it goes. And on the P, when I made that example, I meant for that just to be an end behavior example and forgot to take it out. So again, I apologize if you messed with that and got frustrated and pulled out your hair. It doesn't factor. Don't worry about that one. But T would have an appearance similar to that one. So again, get a hold of me. If you need me for something, play back through these again, look in your book. It's got good reference material. And good luck with the graphing.